Hi everyone, today we're going to study application of quadratic functions. Let us have this example. The quadratic function h of t equals negative 16t squared plus 176t plus 4 models the height of a volleyball hit straight upwards with velocity 176 feet per second from a height of 4 feet. Letter A. How many seconds will it take the volleyball to reach its maximum height? Letter B. Find the maximum height of the volleyball. Take note, our height denoted by h and the measurement is in feet, while time denoted by t is measured in seconds. Let us first copy our function, and it is now written here. And then let us collect the a, b, c. It means our a is the coefficient of the t squared, which is negative 16. The b is the coefficient of t, and that is 176. C is the constant, which is 4. So we have here a quadratic function with the value of a as negative 16. So we have here a parabola that opens downward. It means to say we have a maximum value. Here is a figure of a parabola that opens downward, and the highest point is what we call the vertex, and the k value is the maximum. And this line here is the axis of symmetry. Now, let us solve for a, and that is finding the time t. In here, we're going to use the equation of the axis of symmetry. And the formula is t equals negative of the fraction b over 2a. Substituting the values, we have the negative of b, which is 176, all over the constant 2 multiplied by a. And our a is negative 16. Let us simplify our denominator. 2 times negative 16 will give negative 32. This negative sign here and the negative of 32 will give positive, and the quotient 176 over 32 will give 5.5, and this is the time in seconds. Let us copy this value opposite problem A. So this is the answer for the problem A. Now, let us solve for problem B. In here, what we will do is to evaluate our function using the value of t that we solved from A. So this is h of 5.5. Let us now evaluate our function, and every time we have t variable, we will change by 5.5. So we have now negative 16 times the square of 5.5 plus 176t, and the t is now changed into 5.5. Then we copy this plus 4. Simplifying further, the square of 5.5, we will simplify that into 30.25. And then plus, we get the product of 176 and 5.5, and that is equal to 968. We simply copy the constant plus 4. Of course, in the first term here, the negative 16 is copied down here. In the next line, we will get the product of negative 16 and 30.25, and the answer is negative 484. So we copy the plus 968 plus 4. Simplifying these three numbers, we have now 488. And this is the height given in feet. Let us copy this opposite problem B. And this is our answer. Take note, the vertex of the quadratic function is 5.5, 488. This is our final answer. Example 2. A backyard farmer wants to enclose a rectangular space for a new garden within his fenced backyard. He purchased 80 feet of wire fencing to enclose 3 sides, and he will use a section of the backyard fence as the 4th side. We have here 2 problems. Let's begin with problem A. Find a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. First, let us illustrate our problem. So here it is. This is the backyard and this is the garden as wanted by the farmer. Let this be the side L or length. Another length is here, and this is the side W. For condition 1, it says that length plus W plus length equals 80. This 80 is the length of the wire purchased by the farmer. Let us simplify this. L plus L is 2L plus W equals 80. Then we isolate W. This 2L we transpose to the right, so it becomes negative. So W equals 80 minus 2L. Let us note this equation on this side. Then we go to condition 2. The condition 2 is about the area of this rectangle. So that is A, that is the area, equals length times width, L times W. From here, we're going to substitute the value of W in terms of L to this area formula. So when we do that, A equals this L times W now becomes 80 minus 2L. Then we multiply this L to the binomial. So L times 80 is 80L. L times negative 2L is negative 2L squared. Let us rewrite this equation into standard form of quadratic functions. That means the higher power should come first. So it becomes like this. A equals negative 2L squared plus 80L. This is the answer in our problem A. Let us copy this answer somewhere here. Then we go to problem B. What dimensions should he make to maximize the enclosed area? Note that in our equation here, this quadratic has negative leading coefficient, that is the negative 2. So the graph or this parabola opens downward. Thus, the vertex will give the maximum value for the area. We know that vertex is a point, so vertex is the HK, the coordinates. Let us now solve the values of H and K respectively. So we start with the H. But before that, let's collect the values of the coefficients of this quadratic equation. So we have the A, which is negative 2. This is the coefficient of L squared. The B is 80. This is the coefficient of L. And the C constant, it's not here, so we write 0. Now let us solve for h, and the formula is negative b over 2a. When we substitute the values, we have negative 80 all over 2 times negative 2. The denominator 2 times negative 2 is negative 4. Negative and negative becomes positive. So we divide 80 by 4. We have positive 20. This value is in feet. Actually, this value is the length. Looking at our figure here, this is the side L. Now, what about the K? The formula is the area formula with respect to L. Our L value is 20, so we have A of 20. We substitute this 20 to the L, so we have negative 2 times 20 square plus 80 times 20. Then we simplify. 20 square is 400 plus 80 times 20 is 1,600. This negative 2 times 400 is negative 800 added to 1,600, so we have 800. We can put the unit of measurement, square feet. Since this is A, that means this is the maximum area. So let us solve now for the W using this formula here. That is 80 minus 2L. Again, our L is 20, so we substitute it here. So we have 80 minus 2 times 20. 2 times 20 is 40. So 80 minus 40 is 40. This is in feet. This is the width. So we have the answers. 20 for L, 40 for W.